As you can see from the title of this video, this tutorial is on molecular formulas and how to determine what they are. By definition, the molecular formula of a compound, right, is defined as the formula that shows accurately the atoms and their ratio to each other the formula that shows accurately the atoms and their ratio to each other in a chemical compound. So, earlier in the chapter we learned about empirical formulas. And empirical formulas were the simplest whole number ratio of two atoms to each other. The molecular formula is what the actual compound's formula is. It is not simplified. It shows, based on weight and proportion to each other, what the most reflective formula of atoms are to one another. Just like we had a way for getting empirical formulas, there's a way for getting molecular formulas. The good news is if you can solve an empirical formula problem, you are about 90% of the way to solving a molecular formula problem. The molecular formula of a compound can be found using a pretty straightforward equation. It is equal to the empirical formula of a compound times some multiplier x. What then is x, and how do we get this multiplier? Well, x is always equal to the molar mass of the compound divided by the mass of the empirical formula when you add them up based on what you get. So sometimes you'll see problems where you're given the empirical formula and you'll always have to be given the molar mass of the compound. And then your job is to get the mass of the empirical formula, find your multiplier, and distribute it in. The other type of problem is where they start you back from a empirical formula problem, and you have to work your way through the steps of an empirical formula, get that first, and then plug in and solve. So we'll do one of each type, just so you get a feel for what those problems are going to look like. But before we do that, I wanted to show you a quick refresher on how we get empirical formulas, and I've left those steps up from a previous video. Right? Determining the empirical formula, remember we first get each element into grams, whether it be from percentages and we assume 100, or we use laboratory data. Then we convert grams into moles, doing one-step bracket problems. Then we divide by the least, and then once we divide by the least, we have to get ourselves whole numbers, right? Whether we get them naturally or we have to multiply them by 2 or 3 or 4 to get ourselves to whole numbers. So sometimes we will use this, sometimes we will not. Taking a look at the first example. It says, determine the molecular formula of a compound whose empirical formula is P2O5 and has a molecular weight of 283.889 grams per mole. Sometimes you'll see this expressed as AMU, atomic mass units. Sometimes you'll see it without any unit. It'll just say a molecular weight of. Right? But all of them are just helping you out with what is the molecular weight of the whole compound or the molar mass. So, Obviously, we're trying to find the molecular formula, so we want to start with this equation here. Abbreviating the equation to save space, molecular formula is equal to empirical formula times X. So, we take a look and see what we have. Do we have the molecular formula? No, that's what we're looking for. Do we have the empirical? You bet. That's P2O5. Do we have X? Well, we have to take a look. X is the molar mass of the compound divided by the empirical formula mass. So if we take a look when we go to find X, the molar mass is supposed to be given to me all the time, and sure enough, it's given to us right there, 283.889 grams per mole over the empirical formula mass. And all we do to get the empirical formula mass is add up the 2 P's plus the 5 oxygens. So what I'll do in my calculator is take 2 times P off the periodic table, which is 30.97, plus 5 times oxygen off the table, which is 16.00, and you'll get a value of 141.94 grams per mole. Simply do the math, solving for X, 283.889 divided by 141.94, and you'll get a number that says 2.000. Here is a rare case where we don't really care about sig figs. We're simply trying to find a multiplier, and 2.00000 is obviously going to be close to 2. So our multiplier is going to be 2. What then do we do with it? Just like math class, you would distribute the 2 into the numbers that were there, leading you to a molecular formula of P4O10. So whenever you're given the empirical formula, the problem is very, very straightforward. All you have to do is find your multiplier by adding up the mass of the empirical formula and then using the number that they give you. Occasionally, this number won't be given to you. You'll solve a different problem, but that won't be till much later in the year when we have a couple more weapons at our disposal, so to speak, that allow us to solve for molar mass. Let's take a look at one that's not quite as straightforward. This one here says, if a compound is found to have 0.44 grams of hydrogen and 6.92 grams of oxygen, determine its empirical formula and molecular formula if it has a molar mass of 34.00 grams per mole. So here is a case where the empirical formula is not given to us. So the first thing we're going to have to do is determine our empirical formula so that we can plug into this equation. So if I list my equation, molecular formula is equal to empirical formula times X. I'm going to have to get my empirical formula and X just like we did in the previous problem. So X in this case is the molar mass over the empirical formula's mass. The molar mass is always supposed to be given to us. Well, sure enough, it was. It's 34.00 grams per mole. The difference this time is I don't know what my empirical formula is, so I can't simply add it up off the periodic table. That means we're going to have to solve an empirical formula problem based on the other data that we have. So we'll slide this to the side, and we'll refer back to our steps for getting empirical formulas. First thing says is determine the amount of grams of each element. Well, I see 2 amounts of grams, 0.44 of hydrogen and 6.92 of oxygen. So we'll start with those. They're not percentages, so we can use them just as they are. Step 2 says convert grams into moles. To do that, grams goes on the bottom, moles goes on top. Anytime you're doing a gram to mole conversion, 1 always goes with moles, and you'll go to the periodic table to get yourself grams. Remember, hydrogen off the periodic table goes 3 places past the decimal. Oxygen only goes 2, but those numbers would be 1.008 and 16.00. So we do some math on these to get ourselves the moles of each substance. 0.44 divided by 1.008. I only get 2 sig figs here, so this number is 0.44 moles of hydrogen. On the bottom, 6.92 divided by 16.00. I get 3 sig figs. It looks like we get 0.43, right? 2.5 with nothing after it means we'll keep that at 2. So you have moles of each substance. Next step says to divide by the least. Looks like the least is 0.432. Bottom one, no surprise, will be 1.00 moles of oxygen. Top one, if we take 0.44 divided by 0.432, it looks like you get 1.01. We only get 2 sig figs though, so we have to call that 1.0 moles of hydrogen. Then we get whole numbers and use those as subscripts if they're close enough to whole numbers. 1.0 and 1.00 are plenty close enough to say that our empirical formula is going to be HO or OH. It does not matter the order. So now we have the pieces that we need to plug in. I needed the empirical formula for up here, so we will say HO times X, and I needed the empirical formula to get the mass. So what I'll do is I'll take H off the table, 1.008 plus O, 16.00, leading me to a number of 17.01 grams per mole. Doing the math on that, again, you don't have to worry about sig figs. It looks like my multiplier is going to be 2. I plug that in up here, distribute my 2 in, and it looks like my molecular formula ends up being H2O2. And H2O2 happens to be hydrogen peroxide. So, anytime that you are given the molecular formula is in the first problem, the empirical, you simply plug it in and solve. It's very quick, very easy. If you were started back a little bit farther, you have to go through an empirical formula problem first and then plug it back into the equation that we listed right here. I hope this helped you out if you were having some confusion. As always, if you are still finding trouble getting through some of the problems, stop in and we'll get you straightened out.